Hi, in this lecture video, I'll be doing a quick introduction to solution concentration, and then we will focus on the percent concentrations as the method of expressing the concentration of a solution. So what is solution concentration and why is it important that we learn about it? And so basically, whenever we make a solution, then any solution would have certain concentration to it. And it's important that we describe and we figure out what is the concentration of a solution. And the reason why this is important is as follows. Let's take drugs and medicine as an example. So when you take in a drug is basically a solution. And let's say that we are giving a patient a particular drug. If this drug right here is too diluted in concentration, then it may not provide the effect of what it is intended for. Versus if we were to now give another drug solution that is now too concentrated, then this can now be lethal and harmful to the patient. So it's important that we make the drug and we give the right concentration of a drug to a patient. So thus it's important that we learn about solution concentration. So any solution will have a concentration to it. And a concentration of a solution refer or basically describe how much solute that is present in a particular amount of a solution. Because we know that a solution would consist of a solute and a solution, right? And the solvent to make up a solution. So how much solute that is present in a particular amount of a solution. That's what is being described by the solution concentration. And there are actually different ways to express the concentration of a solution. For example, again, we see that a solution concentration describes the amount of solute in certain amount of a solution. And the amount of solute may be described in gram or volume if it's a liquid, or maybe in mole as well. And as for the amount of a solution, it can be gram of solution or volume of the solution as well. So how many gram of solute that is present in certain gram of a solution? If we were to focus on those two amounts right there of the solute and the solution, then this unit right here, or this method right here, is then referred to as the percent by mass. And that is one way of expressing the concentration of a solution. We can also describe the amount of solute in terms of volume if the solute happens to be a liquid. And now when we have a solution, we have certain volume of it. And if we were to now describe the volume of a solution in volume as well, so we have volume of solute to volume of solution. This method right here would then be known as the percent by volume. And similarly, we can also describe the amount of solute as mole, and now the amount of solution as volume. And this method right here will then be known as the molarity. In addition to the example that we have seen up here, right here, then there's also several other methods of expressing the concentration of a solution as well. And different methods have different application to them, because depending on in what setting that we are in, it will be more convenient to use one method of expressing the concentration over the other. So we'll be going over this different method right here and understand why that we need to use them. Okay, and very important, the concentration of a solution are basically conversion factor. This is the conversion factor that convert the amount of solute into the amount of solution. So therefore, as we take out certain amount of the solution, and we know its concentration, we can then figure out how much solute that is present in it. So basically, therefore, we call this the conversion factor. And so it's important that as we learn about these different concentrations and different method of expressing the concentration of solution, that we know how to use them as conversion factor. And the two important methods for expressing the concentration of a solution can be summarized as follows. First one is the percent concentration, which we have seen the percent by mass and the percent by volume here. And here in this case right here, we'll go over this unit right here in more detail. And the second method would then be the molarity, We also have molality as well, but then that is not a very common unit, and so we'll not be discussing that here in this lecture video. So now, let's go over the percent concentration first, the first method of expressing the concentration of a solution. The percent concentration can be further divided into 3 different types. We can have percent by mass by volume, and percent mass by volume. So let's go over each of this in deeper detail. So first one, the percent by mass. To abbreviate this, we can do a percent and m over m. So m over m means mass over mass. So percent mass, that's what that means. Sometimes we can also weight over weight as well. Percent weight over weight, mass over mass, and weight over weight are essentially the same thing. And so in this method right here, we are expressing the mass of solute over the mass of a solution. And now this is being expressed as a percentage. So the percent by mass based on this description is then equal to the mass of solute, or gram of solute over gram of solution. We can either have gram over gram, pound over pound, so whatever that unit of mass will be. But gram over solute over gram of solution multiplied by 100. And that is how we would be able to express what is the percent by mass of a solution. And if we were to now elaborate further on this, we would then see that the mass of a solution is then further equal to the mass of the solute plus the mass of the solvent. So that is how we can figure out what would be the mass of a solution. And where this type of unit right here being used, and then to give you an example, first, milk. We all have drink milk, and sometimes when we see on the label, we may have 1% milk, 2% milk, 5% milk, or whatever percent of milk may be. So what does that 1, 2, or 4% means? And so this means the following. If we were to have a 1% milk, it means that there is 1 gram of butter fat per 100 gram of milk. So if I were to now weigh out 100 gram of this milk right here, it will then have 1 gram of fats in it. So that is where we see this unit being used. And now let's go over an example to make sure we know how to calculate what is the percent by mass of a solution when the solution are being prepared in a certain way. So let's say here the first example right here. A solution is prepared by dissolving 1.23 gram of sodium chloride in 500 milliliter of water. So now, how do we calculate what is the percentage by mass of this solution? And if we were to recall this equation right here, the percentage by mass, or percentage of m over m, would then equal to gram of solute over gram of the solution. And here in this case right here, we would then see that sodium chloride is the solute, and its mass is 1.23 gram. So we then wouldn't have 1.23 gram of solute over the mass of the solution. So here in this case right here, this solution consists of sodium chloride and water combining together. Now, we are given the volume of water, not the mass of water, but because the density of water is 1 gram, or roughly 1 gram per milliliter, we will then see that this volume right here will then weigh 500.0 gram of water. And now we can add the mass of water and the mass of sodium chloride together to get the mass of the solution. So in this case, this equal to 1.23 gram of sodium chloride plus 500.0 gram of water. In this case, the solvent, and multiplied by 100. So this would then equal to 0.245%. And now, since there are different units of the percent by mass, it's important that we describe what is this unit right here. So here in this case right here, we will put m over m to let people know that this is the percent by mass right here. And follow, we would also include the formula of the solute as well. So how we would label this solution is as follow: 0.245% m over m NaCl. So we would include this as well, because we know the solvent would then be water. since these are aqueous solution. So it's important that we specify what is the solute. Now let's try another example. So why don't you take a minute to work on this problem before we go over the answer together. And now let's go over the answer. So here in this case right here, we have a solution that contains 27.5 grams of ethanol and 175 milliliter of water. What is the mass percent? So the mass percent is same thing as the percent by mass. They imply the same thing. So here in this case right here, percent by mass, percent M over M, would then equal to again gram of solute over gram of solution. And here in this case right here, ethanol is the solute, and we have 27.5 grams of ethanol. And over the mass of the solution. So here's again, we are given the volume of water, but because the density of water is rounded to 1 gram per milliliter, so here in this case right here, this much of volume of water will then weigh 175 grams of water. So by combining the ethanol, which is 27.5 grams, and the water, in this case that is the solvent, 175 grams, multiplied by 100, so this would then become 13.6%. And again, it's important that we specify what is this percentage right here. In this case, this is the percentage by mass, so we also include M over M. And in this case, the name of the solute, which is ethanol. And that is how we would label this solution right here. And now let's go over the second method of using the percent concentration. So here in this case right here, the percent by volume. And we abbreviate this with percent V over V. So V here is mean volume. So volume over volume. In this method right here, we are basically express the solute in terms of volume. How many milliliter or any unit of volume of the solute do we have over the volume of the solution. And we express this as a percentage. So this is the kind of unit that be very commonly being used whenever we have the solute as a liquid. So it would be easier to measure out by measuring its volume. So therefore we would not be describing the amount of the solute as a in terms of volume. And that's why we would use this unit. And as it been defined, percent by volume equal to the volume of solute over the volume of solution multiplied by 100. And so where this type of unit being used, then the answer, alcohol beverage. So most wine basically 12% by volume. What this means is as follows. If we were to have 100 milliliter of wine, there would then be 12 milliliter of ethanol or alcohol, the ethyl alcohol that is present in that wine right there. So again, that's an example of where we see these types of unit being used. And now, note one thing that is very important in here. So on the bottom, we see volume of the solution. But notice the following. The volume of the solution is not additive of the volume of the solute and the volume of the solvent add together. And this is very different compared to the mass of the solution. We will then see that the mass of the solution is additive of the mass of solute plus the mass of solvent. However, volume are not additive. And so the explanation is as follows. Let's say here we have 150 milliliter of one substance A. And now we combine that with another substance B with also 50 milliliter as well. So when we combine A and B together, these two different substances, we would expect the volume to be 100, right? So this is the mark right here for 100 milliliter. So when we combine them into this larger volumetric flask, we would expect the volume to be 100. But we can see here in this case right here, this is smaller than 100. So this is an example right here to indicate that when we combine substances together, their volume would not be additive. And an explanation to make sure you understand this is as follows. Let's say here we have a beaker of a golf ball. So let's say this golf ball right here is a raw chemical substance. And there we have a beaker of it. So would we say that this beaker right here is full? And the answer, yes, is look full. But the question is, can we still add more to it? Well, we won't be able to add more golf ball to this. But if we were to now have a bigger or more ball, we can actually add this more ball to this. And this would not be overfill. So basically, when we add these two volumes together right here, the volume would not be that much higher or additive of these two volumes right here add together. And the reason why as follows. Among this golf ball right here, there's still empty space in here, in which when we add in the marble is small in size, so we'll be able to come in and occupy this empty space right here. So therefore, it do not take in extra space, and that's the explanation why the volume of a solution is not additive of the solute and the solvent add together. So please keep that in mind. And now let's try an example of how we would use and calculate this percent by volume right here. So here's an example. A 125 milliliter sample of mouthwash contains 12 milliliter of ethyl alcohol. What is the percent by volume concentration of this solution? So in this case right here, the percent by volume, so percent V over V, would then equal to volume of solute. And the volume of the solute can be any unit. It can be milliliter or gallon or do not matter. But make sure the volume of the solute and the volume of the solution have the same unit. So here, volume of solution. And now in this case right here, we have 12 milliliter of ethyl alcohol. So 12 milliliter. So now that tells us that we have to convert the volume of the solution into milliliter as well. And here in this case right here, this mouthwash right here is our solution. And here we've been told its volume is 125 milliliter over 125 milliliter of the solution multiplied by 100, and this would then equal to 9.6%. And again, we have to specify that this is the percent by volume, so we would label that by putting V over V. Okay. And now, so here in this case right here, we have 125 milliliter of this mouthwash right here. And within it, there are 12 milliliter of ethyl alcohol. That allow us to figure out how much volume would then be water. And the answer is no. We do not know how much water is in it. So please do not take 125 and minus 12, and whatever that answer equal, and that becomes the volume of water. The answer would not be correct, because when we take the ethyl alcohol and the water and we combine it together, it will not add equal to this volume of the solution right here. So please be aware of it. So here in this case, we do not know how much is the volume of the solvent or water in this example. And now, lastly, let's go over the third the third units of percent concentration. And this one is the percent mass over volume. And we abbreviate this as M over V. So in this method right here, we have the mass, we have the solute that is now being reported in gram, in mass, and divided by the volume of the solution in milliliter. And we now express this as a percentage. So the mass and to the volume percent would then equal to the mass of solute in gram over volume of the solution in milliliter multiplied by 100%. So where do we use this type of unit right here? And then the answer, in many clinical and hospital settings, such as IV solution. So if you have IV solution before, then the concentration of the IV solution is been reported in this types of unit right here. So this is the types of unit where we would use whenever we have a solute that is solid, and now we dissolve that in a solution. And normally this type of solution right here is quite diluted, and that way we would see this types of unit being used. Now, please be aware of one thing, and this is really important because a lot of students get confused by this. When we look at the unit of this mass by volume percent right here, we see gram over milliliter. And a lot of students will be jumping to conclusions and say, hey, Isn't this the same thing as density? Because we have seen already the density at the unit of gram over milliliter. But density is completely different compared to the mass to the volume percent. And the reason why is as follows. In density, we have gram of a substance over volume of that substance. So the substance are the same, right? Mass of a substance over volume of that same substance. But here, in the mass over volume percent, we have gram of solute over volume of the solution. So these are not the two same substance right here. So please be aware of that. So again, the mass to volume percent, even though we see the unit gram over milliliter, it is gram of solute over milliliter of solution. And this is not the same thing as density. And now let's try an example to make sure we know how to calculate the mass to volume percent. So here in an example, a solution is prepared by dissolving 10.0 gram of glucose in enough water to give a 325 milliliter of solution. So in this case right here, we don't know how much water is being used, but we thus know that we just add enough to bring the volume of the solution to 325 milliliter. So what is the mass to volume percent concentration of this glucose solution? And now let's calculate this. So in this case right here, percent M over V, and we would have gram of solute over milliliter of solution. And in this case right here, we have our solute is glucose, and we have 10 gram of it. So 10 gram of glucose over the volume of solution. Here in this case, 325 milliliter of the solution. And then multiply by 100. So this would then equal to 3.1%. And again, we have to distinguish this mass volume percent right here compared to the other percent by mass or the percent by volume. And to distinguish that, we have to now label this as M over V, so it becomes clear. And in this case right here, the solute is glucose, so we also put glucose along with it. And this is how we will label this solution right here. Now, so here in this case right here, we will have to round this answer right here to 3 significant figure. So I have here only 2, but make sure you round this to 3 significant figure. Okay. So quite easy to calculate the mass to volume percent. But one thing that we also want to make sure here in this case is that we only know the volume of the solution. We do not know the volume of the solvent. Okay, so please remember that. We do not know the volume of the solvent. And now, very, very important. This is perhaps the most important part of this lecture video right here that we want to make sure you pay attention to. So how do we use this different percent concentration right here as conversion factor? Knowing how to use all of this percent concentration right here as conversion factor, this is really the key to solving chemistry problems. And because we have learned already that we use dimensional analysis to solve word problems in chemistry. And in order to do that, we have to make sure we know how to utilize information as conversion factor. So the different percent concentration can actually be used as conversion factor. And it's important that we know how to do that. And here are a few examples. If we were to have a 15% by mass of NaCl solution, then this means as follows. If I were to have 100 gram of solution, there will be 15 gram of NaCl in it. So that's the meaning to this percent concentration right here. And from this meaning right here, I can now write a set of 2 conversion factors that are reciprocal, in which I can have 15 gram of NaCl over 100 gram of the solution. Or the reciprocal of it, where I have 15 gram of NaCl on the denominator and 100 gram of solution on top. So it's very important that we know how to convert this percent concentration into this correct conversion factor right here. And similarly, If we were to have a 6% by volume of methanol solution, then this basically means, again, anytime we have the percentage, we can now assume on the denominator it will be 100, and the unit on the denominator will be the solution. So in this case right here, 100 milliliter of solution. So if there's 100 milliliter of solution of this solution right here, there will then be 6 milliliter of methanol in it. And again, from there, we can write 6 milliliter of methanol over 100 milliliter of the solution, or the reciprocal of it. And similarly, when we have a 25% mass by volume of sucrose solution, then this means that there are 25 grams of sucrose in 100 milliliter of the solution. And from there, we can write these two fractions right here that are reciprocal. Okay, so knowing how to convert this information right here into conversion factor is again really, really important. Now, in addition to the set of conversion factors that we have listed above here, it may be possible that we can also come up with the other conversion factor as well that are not listed in here. So how do we come up with them? And it's very important that, and it's very useful for us to be able to come up with the other conversion factor as well that are correct. Because the more we can see relationship and we recognize conversion factor, then and it will then allow us to be able to solve the problem in a much quicker way. Okay, and so here's an exercise right here. List the other conversion factors that are possible based on the percent concentration on the table above. So now let's take a look at the solution A. On this solution A right here, these are the sets of two fractions that are reciprocal right here that we have came up with already. So the question now is, in addition to this set of conversion factor, are there any other conversion factor that we can also write as well? And the answer is yes. Because here's what happened right here. This is the percent by mass. And we know that the mass of the solute and the mass of the solvent are additive to form the mass of the solution. So if I would have 100 grams of solution and 15 grams of it is the mass of solute, that means 85 grams of it would then be the mass of water or the solvent. Isn't that correct? And the answer, yes, we know that for sure. Because again, mass of solute and mass of solvent are additive to the mass of the solution. So in this solution right here, I know that there are 85 grams of water in it. So now I can write this conversion factor. 85 grams of water over 100 grams of solution. So water is the solvent over the 100 grams of the solution. And of course, I can write another one that is reciprocal to this one. So the question now is, if there's any other unique conversion factor that can also write as well. And the answer is yes, there is another. I can also write a conversion factor that relate the amount of solute and the solvent together. So we can see here in this case right here, the 15 grams of NaCl in this solution. And this solution right here contains 85 grams of water. So now I can also write on the bottom 85 grams of water. So that would be another unique conversion factor that I can write. So this conversion factor right here shows the relationship, and it will allow me to convert between gram of water to the mass of solute in it. And this one right here, the mass of solution to the mass of the solvent. And the other one with the mass of the solution to the mass of the solute. So these three conversion factors right here will allow me to do different things. And so again, it depended on what is the problem that asking us to do. That's how we would be able to decide which is the appropriate conversion factor to use. So now, if we were to now look at the solution B, would it be possible for us to come up with other conversion factor similar to the solution A? Can we write 94 milliliter of water over 100 milliliter of solution? What do you guys think of that? Can we write this conversion factor right here? Is it correct? And the answer is no. It would not be correct. Okay. And the reason why is volumes of the solute and the solvent are not additive. So when we combine them together, if we were to actually take out 6 gram of solute and then 94 milliliter, 6 milliliter of solute and 94 milliliter of water, and we combine them together, it may not and very likely will not add equal to exactly 100 milliliter of the solution, because again, volume are not additive. The volumes of things would only be additive if they are the same thing. So when we combine water with water, its volume will be additive. Or when we combine one alcohol, and the same alcohol, then its volume will be additive as well. So again, its volume will be only additive when we are adding the same thing together. And which brings us to this point right here. If I were to have 2 aqueous solutions, when we combine them together, will their volume be additive? And the answer is yes. And because this are aqueous solution right here, so their solvent are the same thing, meaning the solvent will be water, right? So we basically combine water with water, and this is why the volume would be additive. So please keep that in mind. When we take 2 aqueous solution and we combine them together, their volume would be additive. So in B, we'll not be able to do that. And in C, let's see if you can come up with any other conversion factor. So go ahead and take a minute and see if you can write any other conversion factor for C. Were you able to come up with any? And if you did not come up with any, then you did it correctly. Okay? Because again, when we combine solid and solvent together, we don't know how they would add together to result in the volume of the solution. So when we combine solid with volume of solvent together, we cannot figure out what their final volume would be. So therefore, any of the conversion factor that you came up with in this solution C would not be correct. So we'll only be able to have this conversion factor right here. So only in the percent by mass that we will be able to come up with the other conversion factor that will be correct, not with the percent by volume or the percent mass by volume. And now let's try a few of this example right here to make sure we know how to solve problem using dimensional analysis and understand how to use this percent concentration right here as conversion factor. So here the first problem right here. A soft drink contains 11.5% sugar by mass. What volume of the soft drink in milliliter would contain 85.2 grams of sucrose? And now the density of the solution is 1.04 gram per milliliter. So how do we solve this problem right here? So whenever we have this kind of word problem right here, it's important that we try and we think about dimensional analysis. And we solve this problem right here using dimensional analysis. So that means that we need to know how to use this percent concentration right here as the conversion factor. So let's just follow the guidelines from dimensional analysis and figure out our starting unit and our wanted unit. So here in this case right here, the starting unit. What is the starting unit? So the starting unit here in this case right here would then be 85.2 grams of sucrose. And the wanted unit would then be, you say, what volume of the soft drink? So the soft drink is basically the solution. So milliliter of the solution. That is what being asked for. So basically this question right here is telling us that how much soft drink that I need to take out in order for it to have 85.2 grams of sugar in it. And the concentration of the sugar in this drink is 11.5% by mass. So once we have identified the starting unit and the wanted unit already, then in order for us to solve this problem right here, we have to convert from gram of sucrose into milliliter of solution. So therefore, that is the conversion factor that we need. We need the conversion factor that relate gram of sucrose to milliliter of solution. So that will be the ideal, so that the ideal conversion factor that we need. Ideal conversion factor is something that will relate gram of sucrose to milliliter of solution. And therefore, we now go to the problem and look for that piece of information right there. So here in this case right here, it is percent by mass. So again, whenever we see the percentage, we know that we can use that as conversion factor. And let's see if this is the right conversion factor that we are looking for. In this case, we see 11.5% sugar by mass. This means as follows: 11.5 gram of sucrose over 100 gram of the solution. So that is how this percent by mass is written as a conversion factor. So it is exactly what we want. And in this case right here, the answer, so we want gram of sucrose into milliliter of solution. But here in this case right here, we see that, okay, this is over gram of solution. And I want something like over milliliter of solution here. So that would not be appropriate right there, right? So this is not the conversion factor that will allow me to solve this problem right here in one step. So what is missing right here? Now, so I know that if I were to start out, if I were to use this conversion factor, I can convert from gram of sucrose into gram of the solution. But how do I get to milliliter of solution then? Well, the answer, the density, right? To be able to get to the volume of the solution from the mass of the solution, the density would then be the answer key. Because density, so that we have been told this is the density of the solution. And what this means is as follows: 1.04 gram of the solution over 1 milliliter of the solution. So please note again that we have solution over solution. Okay, not solute over solution, but mass of solution over volume of the solution. So the solution map would then be as follows. We would then start with gram of sucrose, and we can then use the percent by mass to get this to the gram of the solution by using the percent by mass in here as the conversion factor. And once we have gram of the solution already, we can then use the density of the solution to convert this into milliliter of the solution. And that will then be the solution map. And now putting all of this together, let's now set up the conversion pathway. So we are starting with gram of sucrose, and the exact value is 85.2 gram of sucrose. And now we're going to first use this percent by mass right here to convert from gram of sucrose into gram of solution. And so the conversion factor is 100 gram of, so we would not be putting 100 gram of solution here, but we should be putting the gram of sucrose on the denominator, right? And here in this case right here, that is 11.5. So make sure we put 11.5 gram of sucrose on the denominator, so that way it can get cancelled out. And on top, it'd be 100 gram of the solution. So that's how we would set it up on the first step. And so now we can see that the gram of sucrose would get cancelled out, and we will be having gram of the solution. And now we have to convert from gram of solution into milliliter of the solution. So in this case right here, we have to use the density. And this is the conversion factor right here. And now we have to put gram of the solution on the denominator. So we have to put this value, put this unit on the denominator. And the value of this is 1.04. So make sure we put 1.04 along with that unit, gram of the solution. And on top would be 1 milliliter of the solution. And now gram of solution will cancel as well, and we will end up with milliliter of solution. So here in this case, this would then equal to 712 milliliter of solution. And the answer needs to be rounded to 3 significant figures. So quite easy to do. So please try these 2 examples right here before we go over this together. And so I'm going to give you the answer so you can check your work. So for problem number 2, the answer is 10.6 gram of sucrose. And for number 3, this is 0.32 gram of NaCl. So make sure you obtain this correct answer right here.